Dry leaves are one of the most overlooked resources in the garden. Every autumn, yards and roadsides fill with piles of crisp, fallen leaves that many people rush to bag up, burn, or haul away. Yet those same leaves are one of the most powerful soil-building materials available to gardeners and land stewards. With the right approach, those brittle brown leaves can be transformed into rich, dark compost in a matter of days rather than months or years. Leaves are considered browns in the composting world, meaning they are high in carbon and relatively low in nitrogen. Carbon-rich materials are essential for building soil structure, but on their own they decompose slowly. This process is called leaf mold formation. Microorganisms that digest plant matter need both carbon and nitrogen to thrive. Without enough nitrogen, the breakdown process crawls along at a glacial pace. Speeding up this process requires three key adjustments: increasing surface area, balancing with nitrogen, and creating conditions where microbes can work at full intensity. When those conditions are right, the compost pile heats up dramatically, and decomposition accelerates in a way that surprises many gardeners. When leaves are shredded, mixed with nitrogen, and managed using hot composting techniques, it's realistic to produce finished compost in roughly 2 to 4 weeks. Inside that pile is a carefully guided microbial explosion. Billions of bacteria and fungi multiply rapidly, generating heat as they break down organic matter. Temperatures inside a well-managed compost pile often reach between 130 and 150 degrees Fahrenheit, which dramatically accelerates the transformation. There are two primary ways to convert dry leaves quickly. The first is a hot composting system like the Barkley method, which produces compost in weeks. The second is a simpler boosted leaf pile or bag method that requires less work but typically takes 3 to 8 weeks. Shredding leaves is the first secret to speed. Whole leaves stack like shingles, trapping air and slowing microbial access. A simple lawnmower is one of the easiest tools for this job. Spread a layer of leaves and run the mower over them several times. This transforms bulky piles into compact, fluffy material that decomposes quickly. The finer the particles, the faster microbes can digest them. For a compost pile to generate enough heat, it needs sufficient mass. A good target size is roughly 4 feet wide, tall, and deep. As the pile is built, shredded leaves should be mixed with nitrogen-rich materials like grass clippings, kitchen scraps, or coffee grounds. When carbon and nitrogen are combined in a 30-to-1 ratio, microbes receive the balanced diet they need. This usually means 3 parts leaves to 1 part greens. Moisture is the hidden ingredient. A compost pile that is too dry will barely decompose. It needs to reach the consistency of a wrung-out sponge. If water pours out when squeezed, the pile is too wet. Maintaining this moisture level is essential. If the pile dries out, microbial activity drops sharply. To kickstart microbial life, add a few handfuls of finished compost or healthy garden soil. This introduces beneficial microbes to colonize the pile. Some use natural accelerators like sugar water or diluted molasses. These provide a quick energy source for microbes during the early stages. Within 3 to 4 days, a well-balanced pile reaches temperatures between 130 and 150 degrees. This heat kills weed seeds and plant pathogens. Aeration is critical. Turning the pile introduces fresh air and redistributes materials from the cooler outer layers into the hot center. In aggressive hot composting, the pile is turned every 2 days. With each turning, the materials become darker, softer, and more crumbly. Within 2 to 3 weeks, the shredded leaves disappear, replaced by a dark material that smells earthy and clean, like a rich forest floor. For busy gardeners, the bag system is easier. Shredded leaves and nitrogen are packed into black plastic bags which absorb sunlight to generate heat. One common issue is dryness. Leaves shed water easily, so piles must be checked regularly to ensure they remain damp for microbial life. If a pile becomes waterlogged from rain, oxygen levels drop and odors appear. Covering the pile with a tarp during storms can help. The finished compost is incredibly valuable. It improves soil structure, enhances moisture retention, and feeds the organisms that support plant growth. Fallen leaves represent the natural nutrient cycle. By learning to harness this, even small piles of dry leaves become a renewable source of fertility. Subscribe to Timeless Humus Path for more soil revival wisdom, and pass this video along to anyone turning waste into living soil.